Welcome to the Sigasi Linting webinar, and thank you for joining. Here is a quick overview of what we will cover today. In this webinar, we'll talk about what linting is, why it matters, and how you can use it effectively in Sigasi Visual HDL. Let's start by looking at what linting is and why it's important. The term linting originally comes from C programming. Back in the 70s, there was a tool called lint that would scan code for what they called fluff, like tiny bits of fiber on clothing. These were pieces of code that would still compile, but might be bad style, dangerous, or non-portable. In digital design, the idea is very similar. Linting means running static analysis on HDL source code to detect potential issues without having to run simulation or synthesis. Let's look at the difference between syntax checking and linting. Syntax checking is straightforward. It's simply about verifying that code is syntactically correct. In other words, it means verifying that code follows the rules of the language so it can be compiled. Linting, on the other hand, is the process of analyzing syntactically correct code for potential problems. For example, reset issues like missing resets or inconsistent reset style, unreachable code or redundant logic that doesn't need to be there, suspicious or problematic constructs that might behave differently than you expect, or stylistic problems such as coding style or naming conventions. So in short, syntax checking makes sure your code is valid, while linting makes sure your code is good. So what are the main goals here? Essentially, we care about code quality, designer productivity, and maintainability. Why are these important? Because getting early feedback on potential problems makes a huge difference. If you catch issues earlier, they are much easier and cheaper to fix. This is called the shift left strategy. The detection of potential problems is shifted left, meaning shifted earlier in the development phase, saving time and effort. In the end, code should be correct and efficient, easy to understand, not just for you, but for anyone else who reads it later. And it should be easy to maintain so that changes and improvements don't turn into a nightmare. Let's look at how linting works in Sigasi Visual HDL. Sigasi Visual HDL runs linting in real time. It analyzes your code as you type. It supports both VHDL and system verilog linting rules. Linting configuration is quite easy, so you can quickly adapt it to your project. Whenever a rule is violated, it's reported directly as a problem, so you can see and address it right away. Problems are categorized by severity. A problem can be an error, a warning, or an info message. In order to configure linting severities, you can simply right-click the project name in the Projects view and select Configure Project Settings. You can then choose either VHDL errors warnings or Verilog errors warnings depending on your project. Each rule can be assigned a severity level. You can configure the severity of a rule as error, warning, info, or you can choose to ignore it entirely. This flexibility lets you decide which issues are critical for your workflow and which ones can safely be ignored. The linting configuration is stored as a simple text file inside the .settings folder of the project. That means the configuration is completely self-contained within the project folder. If you share the project with your colleagues, the linting rules go along with it. And if you want, you can edit the text file directly. The editing syntax can be found in our manual. Now let's switch to the tool and see how this looks in practice. Let's go to the Projects view, right-click the project name, and select Configure Project Settings. On this project settings page, there are two sections.